Can you hear me? Good. Okay, so I'm going to talk about, you know, it's been a couple of years now, so I have only 25 minutes, so it's going to be a rough overview, but please feel free to ask me offline about any technical things that go behind this. Also, before I forget, we have a workshop at ICSI Multimedia on geolocation technologies, you know, in this kind of sense, and maybe other kinds of senses that you came up with. So if you're interested in that, the deadline is soonish, end of the month. So please take a look at the call. Okay, so I'm going to talk about multimodal location estimation. So because this is a rather new field, the question is, what is location estimation? Well, location estimation is exactly that estimating the geocoordinates of the origin of the content recorded in digital media. Of course, there's all kinds of localization techniques like for robots and so on. What we are talking about is giving a video, and the computer should tell you where the video has been recorded. Of course, you could embed geotags, and then it's easy, but of course we talk about not having geotags embedded. We're talking about a regression. So again, where was the video recorded, latitude, longitude, and also altitude. I've never seen anybody work with altitude, but rather trivial problem here you have that. And this task, you know, I sort of first gave a talk on this at the Berkeley topics meeting in Florence. So some people remember that talk, and if they do, please bear with me because the couple of first slides are the same. So one thing that's cool about this task, and that's actually how we thought about this, is because, you know, again, in speech recognition, if you collect the corpus, the most expensive thing is actually annotating it. For this task, the annotation comes for free. On YouTube, we estimate there's about 3% of all the videos have geotags. That's about 3 million videos. And on Flickr, 4.5% of the videos have geotags. That's about 180 million videos. And then, of course, there's more than that photos being geotagged. So basically, even the geotag is not always accurate. You could use this data for training. And of course, that's training on a scale never seen before. We talk about millions of videos. The bottleneck is not the data, the bottleneck is the compute. Of course, then, cool, now we have an interesting academic task. Is that actually useful? And actually, there are a couple of uses. First of all, geocoordinates in time are a unique ID. That's why every social networking now tries to get your location. So it's really good to identify and track you. Whether that's good or bad is your own choice sometimes. But basically, it's a really big hype, and there's lots of technology being enabled by geolocation. Secondly, there's another application, which I actually could explain to you, but I opted, again, especially given the coffee break is soon, to rather show you a video from TV that basically explains that application. And I think it does a better job than I could ever do.
How can I be sure she's still alive?
I sent you an email. Say hi to your friends, Agent Shaw.
Go to hell, Tom.
There's no reflective surfaces and the windows are all blacked out.
Not all of them. Look. What's out that window? Zoom in.
What are those? Buildings?
Bridge towers.
Call up all the bridges in the city, see if our partial VFX.
Ah, the Whitestone.
We're still hanging out the corner to find the axis.
Play the audio again, but this time without the voices. And get rid of all the traffic as well.
That's a subway. And not just any subway.
Those are elevated tracks.
I'll pull up the subway map. See where it intersects with the approximate line of sight.
That's the IRT Pelham line. What's the stop that intersects? Zarega Avenue Station. Got it. 1756.
So while there's a lot of science fiction to this video, even though, by the way, it's not full of science fiction, there's a lot of interesting ideas to it as well. And having worked with this for a couple of years now, it's actually way more parallel to what we actually do than you might think. Of course, we cannot just zoom in arbitrarily, and of course, we cannot just filter out the noise from the speech. That would be really fun. But there's a couple of things that they do, especially narrowing down positions by features, that they exactly do the same way. The other thing is what we do not do is what they show here is the interaction between human knowledge and computer knowledge. But there is a whole output program on that right now. We do fully automatic. In the end, though, this is yet another interesting application. It's definitely interesting enough for funders to fund this. And then there's another motivation for not doing this, by the way. So I want to raise the issue that if we do geolocate every video on the planet, then we have a lot of privacy issues. I wrote another paper on that, but I don't want to go in here, but it's kind of fun to be like neutral enough to switch sides from time to time. In any way, it's not, doing this is not completely my idea. Of course, there is now really a big community on this. And the big community basically involves parallel in the US and in Europe. And in Europe, we have, headed by Martha Larson, the media eval benchmark. And one of the media eval benchmark tasks is to automatically guess the location of a Flickr video given one or more visual or audio content, metadata, title, text description, and social information that these people actually go into Facebook posts and so on if you wanted to. And they call it placing task. Well, different continent, different terms, but same. So what they gave us, again, is about 5,000 Flickr videos. They look like this, so no pre-selection at all. It's really random Flickr videos. The only pre-selection is that the ground truth that they have, both for testing as well as for training, is at least 10 meter accurate. And there's another thing that is, there is no intersection between users in testing and training. That's the only pre-selection it is. Other than that, videos are really like this. Could be outside, inside, in water, underwater, at night, black and white, whatever. So again, the training data was about 5K Flickr videos. We had the metadata to it, that means text and descriptions. We had visual keyframes and features, and we had the geotags for training, of course. And on top of that, in 2010, we had 3.1 million Flickr photos plus metadata plus visual features. In the 2011 evaluation, they just doubled that. So we had 10,000 Flickr videos and we had 6 million photos and videos. And the test data was in 2010, 5,000 Flickr videos, metadata, visual keyframes, and features, and of course no geotags because they had them. And also it was doubled in 2011. So how do we go about this problem, by the way? What's the intuition behind it?
Skunk, there's no need.
So yeah, I'm showing you a video now, and you can tell me where you think it's wrong.
Skunk, there's no need to break contact. Yeah. Okay. Dig this. Spit on a stranger. Ready?
Okay, so I'm not going to do more than 10 minutes video. The point here is, visually, or, acoustically, maybe. So it's not going to work if you just look at one modality. So basically our approach is that we say this is hard enough of a problem. There's going to be enough videos that are easy, but there's going to be enough videos that are impossible to locate. And of course the question is, where's the boundary and how can we push this, right? And so we say, in order to approach this problem, you have to take into account everything you ever get. Especially when we have so much training data, this is the chance. So at the end, we say, we do one full approach. So let's look at this Flickr post again, and then you'll see it's actually a little bit easier if you have the extra information. And where is it? Okay. So before I do this, of course, the point here is the intuition of the approach is to investigate the spatial variance of features. So basically the idea is if some feature in the training set occurs only in a certain place, it's probably spatially dependent. If it occurs all over the globe, it's probably spatially independent and we're not indicative of the location. So let's look at the video again with a little more information. So now what we have here is, and of course I'm just making this easier for you. It's not just that we can only locate videos with text, but I want to give you the intuition of the approach. So now you see here in the text, you see pavement, you see portrait, Greek theater, spit on a stranger, live know, by the way, video is a town and reserve, but that's not what's wrong. But just to give you about how so what we do, and just picking this example to make it more visual for you. So now you go ahead and say, okay, let's look at these terms. This could be either, again, the text. This could be NLP descriptions, descriptions of all the text. These could be audio features. This could be video features. I'm going to talk about those later. But this is the general idea. We look at the training set and we say, what are which of these features, or in this case tags, match the training set? And then we look at the spatial variance. So for example, if you have 14 matches for Berkeley and the spatial variance is rather low, that's a good indication. If you have 2,967 matches for video and the spatial variance is about half the globe, that's a bad indication. Right? So that's pretty much how it works. And what happens then is we actually estimate, because the best estimate, the correct answer would be the Greek theater in Berkeley. And the Greek theater, of course, unfortunately didn't match the training set. But if you just match the center of Berkeley, then you get to 300 meter effort. Right? So that's how you have to think about this approach, just to get the overlapation. Okay, then how do we do this visually? Well, visually, it's the same assumption. We say similar images are probably from similar locations, right? And that is an interesting assumption, because we definitely not always true. Like if I take the image of, whatever, a book, I can take this wherever. But of course, I would assume that there are so many books in my data set that the spatial variance of this book is really small, right? It's really high, so it's not even because of the spatial variance. And so what we do there is we use color histograms as feature, and also GIST. GIST has proven to be very helpful. And of course, that's not a surprise. I'm talking to visual people here. So GIST was made for that. GIST was made for basically the global sort of features of the image, which is basically categorize natural scenes as well as animated scenes. And that's why it was really like super helpful for this concept. However, though, and that was one thing. So we started using tags. Tags gave us wonderful results. We added visual and made it way more stable. But then, the audio people were like, audio. What would be interesting? I mean, the text people buy that. This is not about us. It's not about audio. So in the end, we said, okay, so let's set up a very simple experiment. And I'm giving you the preliminary experiment first, before I give you what we do now with audio, because it's still, I find it very interesting that this works at all. So what we did is, we said, so somehow audio must be a digital implication as well, right? So for example, ambulances have different sounds in different cities, right? And if you have a river flow, then that's indicative of a river. So that there must be some audio signals, birds singing, have different song structures. But then of course you have to find out this data. So how do you find this? So what we said is, well, let's not care about this. Let's just say different places will have different acoustic signatures somehow. And unfortunately, due to data space scarcity, the initial experiment could only be done for major cities, because we didn't have a water for like the Sahara desert. No question. So, and then what we said is, also we don't know how to do it anyway. Let's just use an open source speed library system to try to do that. And so I'm now giving you basically the same experiment, but I'm asking you to justify. So I'm going to explain now an audio to you and give you a choice of 30 cities where this audio will come from. And I'm asking you to guess where it comes from. So everybody's silent because you need to listen. the point is, somebody then actually came to me and said, you know, now that you say it's a train, the Shinkansen has a very specific sound. And it's, you know, of course the Shinkansen was a long way, right? It could be anywhere between, you know, North. But the point is, it's actually from Tokyo, and it's really funny that when we look at this particular snippet of audio, yes, it matches Shinkansen bullet trains. And more interestingly enough, this is the highest confidence results of all the 10,000 videos. So what's so interesting about this is that even humans have a hard time. The computer seems to pick this example with really high accuracy. So it's highly non-intuitive how audio works. And in fact, that's like our biggest challenge right now to find out why it doesn't really work so well. Because the second highest confidence and so on are by far not as intuitive as the Shinkansen. They just work. They don't, nobody speaks. And for San Francisco, we figured out it's some word that you just can't avoid. So there's really stuff that is very local specific that you can match to these videos. And there might be really some. Yeah, and again, it was talking about the past sport. So the question also, of course, and I'm giving you also the results of this, the audio results, given this preliminary experiments, we took 540 videos of these 30 cities, and we did 9,700 tries, right, an ID experiment. And of course, random chance would be about 50%. We are at about 52% equal error in which we call, and of course, you can tune that curve in either direction. But given we used a system, a speed ID system, that was not made for this task at all. It was just basically, you know, let's first shot at this. You were really surprised how well it works. So now, of course, the question is, how can we do it more specifically? How can we actually really incorporate it? And this is our ICSI paper. And also, given I only have like 3 minutes left, I can't really talk about all this. But what we do is we basically create a giant belief propagation network that spans like all the training data and all the test data. And basically we include the textual, visual, and the acoustic features so that we know the locations of those videos, and then they are correlated using common text or close visual distance or close acoustic distance. We have this large net. What's so funny about this is that this net solves 2 problems as well. And again, it's Google nice and we talk with nice and so what's so funny about this is it does 2 things. First of all, it corrects automatically the training data, because the training data is only 10 meter accurate. It's not really completely accurate. But the more examples you get, the more accurate you can be, especially in the visual domain. And the second thing, what it does is use an automatic way of saying, okay, so look, I have all this audio, but I don't know where to put it. But all the video seems to correlate, so that means all this audio seems to be in this place, so it solves the integration problem quite nicely. Yeah, so I'm giving, I think I'm just looking at this, I'm running out of time. I'm just giving you the results right now. So the results right now are that we can, these 10,000 Flickr videos that we can classify in 2012, and again, this is my underwater, this is my audio, that we can about, total result is to get about like 8% within the radius, or about 15% within the 100-meter radius. I mean, that's, if you think about this, there's only 3% of videos geotagged. If you add this to 10-meter accuracy, then now you get 8%. You just triple the space of geotagged videos, right? And then if you just not, if it doesn't have to be that accurate, you can go, you know, 100 kilometers is already in the 70%. That's actually, I find that I was totally surprised. Like, there are a couple other sites that have similar results, so it's basically an interesting, it's not clear how humans can do it. And in fact, it's really not clear, and we have one project to actually find out what the human baseline is using mechanical crowdsourcing experiments. And right now it looks like humans are much, much worse. So even though our retrieval capacities are, of course, not perfect, we're all working on this. The point is, the dictionary, the memory, that you can look up the entire world, that actually beats it. So the bottleneck is not the retrieval accuracy, the bottleneck for doing sort of stuff in humans, you haven't visited there are lots of problems. I'm not saying this is solved at all. I think this is a start for an interesting field. One problem is I'm showing you these scores, but there's a huge infrastructure bias because data from social networks, which we use in Flickr, has a huge infrastructure bias. That means there's lots of videos from New York City, there's lots of videos from Los Angeles, but there's pretty much no videos from Africa. So it's just basically, population density times technology to the state of development of the area. And then also, again, even GPS is accurate. How do you deal with ground truth issues? The point is, yes, 4.5% of Flickr videos have geotags, but only, maybe, I would say 20% of that are attempted accurate. And then also, how would you collect the corpus? How would you have humans correct that? That's a problem when humans are not that accurate. Like, if it's better than human, how can you judge? How can you make this better? And then, again, how do I find a video from Africa? I don't know. But I can't do the space there. There's stuff you've never seen. Then you get into the same issue as in all the other times. You probably need to build up some semantic way of finding out where you're from. And then the other thing is, while I'm doing this and I'm presenting very proud of this project, what I'm actually doing for people's privacy when I find out, where every video is coming from. So that's something I actually urge everybody to think about the project because now you can actually look at it. And so this is just basically visualize the infrastructure bias. This is Flickr video density. Of course, red is high density, green is less density, and dark is low density. And again, 4 areas here, 4 areas there, and there.
So Tokyo is a good guess there.
Tokyo is a good guess. By the way, if we have no indication where the video is from, we use the prior. And the prior is pretty much exactly here. It's New York City. So someplace in the head. So whatever video you're taking here, yes.
So how much worse is your performance compared to the prior as opposed to random?
How much better do you No, it's much better. Don't worry about it. If you put all the videos into New York City, it would be much, much worse. So also because, again, even just locating New York City videos is, we're talking about 10 meter accuracy. So then, and actually, if you like Mechanical Turk, whatever, please feel free to contribute. Or it's actually, I don't think any of us will make money on this, but we designed this as a game. It's really fun to play. It's addictive. So I'm warning you right away. People might know this Where in the World game from Picasso was the same way. So we designed it sort of like this, except now it's video, so it's even more getting your attention. And you definitely see the world playing this game. It's a lot of fun.